Okay, today we're going to do a topic called Pythagorean trigonometry, and let's just take a look at a question here. You start off, and you're given something like this. You're given that the root 7 multiplied by the tangent of theta minus 3 equals 0. And you're told that theta is an element of it somewhere between 90 degrees and 270 degrees. And you're supposed to figure out the sine of theta and 4 cos squared theta minus the sine of 180 degrees plus theta. Okay, so what you do, the first thing you've got to do with this root 7 tan theta minus 3 is you want to find out what tangent theta is. So you just solve the equation. So you'd add 3 to both sides and you divide by root 7. Now, if you do that, you'll get that tangent theta is equal to 3 over root 7. So we've got that. And we know that it's between 270 and 90 degrees. Well, there's 90, there's 270. So it's somewhere in these two quadrants. But we know tangent theta is 3 divided by root 7, and that's a positive number. Well, tangent is positive, but it lies between 90 and 270. That means that the angle that you're looking for must lie in the third quadrant. And so you draw a picture like this. You draw a picture just like this, and you just make a triangle here. It doesn't really matter what, you just need a triangle right here where you've gone to the left, down, and then there's the hypotenuse. You know, the reference angle, there's where theta is. So you draw your triangle with the horizontal like that. Okay, so that's where it is. Well, you know that the tangent is opposite over adjacent, and it's 3 over root 7. Well, if this is your angle right here, theta, then you can get that the adjacent side must be, opposite must be minus 3. There's opposite the angle theta. And I think we better, let's put in that theta angle there would be good. Let's put in the theta angle. Let's put it right in there. Make it a little bit bigger. Okay. So that angle right there, that's the kind of reference angle right there you're talking about. And we know that, there it is, there's theta. And we know that we know that it's 3 over root 7, so it's opposite over hypotenuse. But I've gone to the left, so it must be negative root 7. And I've gone down, so it must be minus 3. But two negatives are what make it a positive. Okay, well, there's the picture. The next step is to use Pythagoras to figure out this hypotenuse side. And all you do is you go minus 3 times minus 3, you square both sides, you add them, and you take the square root. So minus 3 squared is 9, minus root 7 squared is 7, 9 plus 7 is 16. And when you take the square root, you get, when you take the square root, you get 4. So root 7 minus root 7 squared minus 3 squared, add them together, take the square root, and you get 4. Okay, well, there, now we've got a triangle with the hypotenuse and all the sides. We can figure out everything here now. We can figure out that the sine is opposite over hypotenuse. So it must equal minus 3 over 4. And that's it. That's the sine. All done. The cosine must be minus root 7 over 4. If we square it, we'll go minus root 7 times minus root 7 would be 7 over 4 squared. Minus root 7 over 4. That's adjacent over hypotenuse, and we're supposed to square the 4, so we got 16 here. But we're multiplying it by 4 in front there. Now this here is 180 degrees plus theta. That's right here. That's 180 degrees plus theta. that sign must be negative. So that's going to turn that into, so because it's 180 degrees plus theta, it must be the minus of the sine of theta, and the two negatives make a positive there. So this part here, I think you might have to show that it's definitely minus sine theta, because sine is negative down there. You just go to where it is and you see that you're in the third quadrant, but two minuses make a plus. Hey, but sine theta is 3/4. You've got 4 cancels with this. You've got 7 over 4 plus 3 over 4. You've got 7 over 4 there plus 3 over 4. The answer must be 10 over 4. Okay, that took a little bit of working out. 10 over 4. And there we go. So that's Pythagorean trigonometry. Okay.